Lesson 29. Lesson 29, we're talking about solving system of equations in three variables. Basically what we're looking at is three equations and three variables, x, y, and z. Now notice this is slightly different than what we're used to. Typically we're used to seeing two equations and two unknowns being the x and the y. But notice with these, all of them have an x, a y, and a z. Okay, so the process, even though we're going to be using the elimination method, is going to change just slightly. So if we take a look at example 1, we have our three equations, and I'll let you go ahead and write those down. And as we go about solving these, it's going to include a 5-step process. So I'm going to go ahead and include a slide for each step. For step number 1, what we want to do is we want to start by selecting two of the three equations. Now, it really does not matter which two you choose. Okay, I'm just going to go ahead and select the first two equations. So there I selected the first equation, and now I'm going to go ahead and select the second equation. And now that I have selected these two equations, the next thing I need to do is to pick one of the three variables and decide which one I want to eliminate. And now if we look at these two equations, you can notice that probably the easiest is going to be the z variable. And just like with the elimination method, we want those coefficients to be the opposites of one another. So when we go to add those, they cancel each other out. So essentially what we're going to want to do is we are going to want to multiply the first equation by 2. So when we do that, when we multiply by 2, we get 6x plus 4y minus 2z is equal to negative 30. Now, the second equation is just fine. Let's go ahead and copy it right below it. So now that we have these two equations, let's go ahead and add and get our variables to cancel out. We have 11x plus 7y is equal to negative 30. And it is at this point we want to go ahead and box this. This is going to be a crucial equation that we're going to come back to after step number 2. Now for step number 2, because we use the first and the second equations, that means we have to go back and reuse the remaining equation that we did not use in step number 1. Therefore, right from the start, for step 2, we need to use the equation 3x plus y plus 3z is equal to 11. And now after you use that third equation that you did not use in step 1, now you can select either of the two equations. You can either use equation 1 or you can use equation 2. And I believe I'm going to go ahead and use equation number 1, which was 3x plus 2y minus z is equal to negative 15. And now basically what we want to do is we want to repeat the process that we did in step 1, and that is we want to eliminate the z variable. So if we look at the z's, I think it's fairly obvious that if we multiply the second equation by positive 3, we get the following. First equation can remain the same. Second equation, we get 9x plus 6y minus 3z equals negative 45. And now if we go ahead and do our addition, starting on the left, 12x plus 7y equals negative 34. And again, just like in step number 1, at this point, let's go ahead and box it, because this is going to be where we lead into step number 3. Step number 3. If you recall, going back to step number 1, we came up with our final equation that we boxed to be 11x plus 7y is equal to negative 30. And then if we go back to step number 2, we came up with the following equation. 12x plus 7y is equal to 34. Now steps 1 and 2 are crucial because that's where we come up with step number 3. And if we look at these two equations, this goes back to what we've done in the past. We have two equations and two unknowns, and it is at step number 3 where we actually do the elimination method that we've been taught. If we look at these two equations, I see that the 7s are very close to one another. Okay, in fact, they're the exact same. The only thing that we need to do is go ahead and multiply one of them by a -1. And in doing so, we come up with negative 11x minus 7y is equal to 30. Second equation, 12x plus 7y is equal to negative 34. And if we add straight up and down, the y's cancel out. That's what we want. We get x is equal to negative 4. And should be at the end of step number 3, you have solved for one of the 3 variables, and that's a good sign. We have found x to be negative 4. Once we find that variable, we can save it. In step number 3, we found the x variable to be equal to negative 4. For step number 4, we want to go back to one of the 2 equations that we came up with at the very beginning in steps 1 and 2. In step number 1, if you go back and look at your boxed equation that you came up with set 11x plus 7y is equal to negative 30. Now, just like we've always done in the past with the elimination method, once we found one of the variables to be, say, x was equal to negative 4, we took that negative 4 and we plugged it into x and solved for y. It's the exact same now for step 4. We want to take 11 times negative 4 plus 7y equals to negative 30. We get negative 44 plus 7y. Adding 44 to both sides, we get 7y is equal to 14. And lastly, we find our second variable to be y is equal to 2. The final step, step number 5. At this point, we have found x to be equal to negative 4. We have also found y to be equal to 2 in the last step. And now, as you would guess, the last step, we want to go back to one of the 3 equations that we originally started with, and we are going to plug in negative 4 for x and 2 for y. So one of the equations that we started with was 3x plus 2y minus z is equal to negative 15. You can choose any of the 3 equations. I just happen to choose the very first one. If we plug in negative 4 and 2, we will solve for our remaining variable. Negative 12 plus 4 minus z, negative 8. Add 8 to both sides. We come up with negative 7. Therefore, z is equal to 7. For the last and final step, I would like you to write your results as an ordered triple in the form of x comma y comma z. Therefore, for our answer, our x was negative 4, 2, and 7.